Good evening, everyone, and welcome to. Good evening, everyone. Hope you're doing well. A warm welcome to the third and final workshop of DataCrunch 2025, proudly organized by the Department of Computer Science and Engineering, University of Moratuwa. We are thrilled to have you all with us here today as we dive into the world of data engineering and MLOps, two of the hottest and most essential areas in building production-grade AI and ML solutions. I'm Lucky Vasam from the organizing committee, and I'll be your host for tonight. Before we begin, let me quickly recap the DataCrunch journey so far. As our first workshop of DataCrunch, we had the Introduction to Data Science workshop organized by our very own Dr. Sandareka Vikramnayaka. And as our second workshop, we had the Time Series Forecasting workshop organized with Zeptagon Private Limited. And today we have our third workshop on data engineering and MLOps with an industry expert. As you all know, the preliminaries of DataCrunch have officially concluded. And yes, we know many of you are eagerly waiting to find out what comes next. Let's just say you might want to stick around till the end of the session today, because we might just have something exciting lined up for you. But for now, let's dive into tonight's session. It's a great privilege to have with us Mr. Roy Ion, a principal data scientist and head of data science and engineering at PICME. With years of industry experience in building scalable, data-driven systems and leading data engineering teams, we couldn't have asked for a better resource person for tonight's session. Without further ado, let me now hand over the session to Mr. Roy Ion.
Hi guys, good evening. Let me share my screen. Hope my screen is visible.
Yes, we can see your screen.
In full screen, right?
Yep, we can see it.
Okay. So hey guys, thank you very much for having me here. So today I'll walk you guys through data engineering and MLOps. So now when it comes to data science industry, we have the buzzwords like AI, ML. Nowadays, now we have the agentic and everything is there. So when it comes to data engineering, it's kind of a bit difficult, I would say. You get some experience, but develop models and all, it's quite easy to gather the knowledge and all. But when it comes to data engineering, it's not that common to get that practice and the knowledge and expertise or get the hands-on mostly experience because you need to have sort of tools and techniques and mostly kind of a different setup and data set. So I thought of walk you through some tools and techniques. I have basically 1 hour, so I'll try my best to give everything within 1 hour. So it's kind of very high level, I would say, 30,000 feet discussion here. So I'll just briefly introduce you basics of data engineering and some practical aspects of all this stuff, especially with related to PICP, where we deal with very quite large amount of data sets. And finally, I'll just touch with MLOps, kind of a not really a new area, but it's kind of a emerging area where a lot of us don't focus on. We have the DevOps, but now we have this MLOps. I'll explain to you what you mean by MLOps, why we need that, etc. So within this period, we can't go in depth, but we'll just cover the breadth. Okay. So starting on now, medical data engineering. So in the industry, we have data science and usually data engineering. So I'll just touch upon only those two. I'll not go into machine learning, those kind of specialized area. I'll just say we have data science and data engineering part. So usually what the data scientists do is they mostly work with the data. So they get the data, so they create these ML of machine learning. So you have the model created by them. When it comes to data engineering, what happens is the role of a data engineer is you bring the data from source to a location where a data scientist can actually use. Okay, so your job is to make sure data is available to be used by maybe a data scientist or maybe data analyst or basically for any use case. Okay, so in basic terminology, we usually call these things ETL jobs: extract, transform, and load. That's what we call ETL. So basically, what you mean by an ETL is there can be different data sources. It can be a basic database, SQL database, or it can maybe a camera, it can be a sensor, it can maybe a IoT device, it can be a vehicle itself, GPS, whatever it is. From a source, you extract. Extract means you take the data, load it. Okay, you take the data and then you do something called transformation. What do you mean by transformation is it can maybe you clean the data a little bit, or maybe you combine the data with something else. So we call it data enriching. Okay, so you do some crunching in the middle before you store them. Okay, so the last part is the loading. So you load them into a separate database. So we call them data lakes or data warehouse. I'll explain them in a bit. So we have that ETL, and then sometimes we might have another thing called let me my pen. Okay, there's another thing called ELTs. Okay, so what do you mean ELT is basically T and L is bit swap. So there can be situation. For example, imagine you are uh, loading data from satellite. We have the satellites. Satellites, sometimes you don't know actually what to actually extracting. So up to a certain time period, you are gathering data. And then only you do the transformation, right? So you have the source and then you load it. You store, keep on storing, and then you do the transformation. Then you can actually get the meaningful insight. So anyway, E is there, extraction is there. Sometimes you load and then do the transformation. You load whatever you get from the source. You don't do any cleanup or anything, just load them as it is. Or you do some transformation and load them. Okay. So in a basic data platform, we have some things called data lakes, and we have things like data warehouses, and nowadays we have these um, lake houses. Okay, so in basic designs, usually we dump our data into data lakes. Okay, so we call them raw data. Now, for example, you may be doing a basic cleanup. So imagine this is your operational data, say post system, or it can be a camera, whatever it is. From the source, you simply extract the data and simply dump it. Okay, so those places, so that place we call them data lake. So data lake will have basically almost everything kind of raw form. And then, but now in raw form, as for BI or for decision making, you usually don't use raw data. No. You need more process data. So then actually what we do is we do another transformation, we do run another ETL pipelines, and we clean a little bit more, and we maybe join in multiple data sets, and then we insert into something called data warehouse. In data warehouse, we mostly have curated data, clean data. Okay, so that's where all these BI do everything actually take the data. It can be reporting, it can be management decision, dashboard, whatever it is. Okay, and sometimes you actually don't dump it into data lakes. You actually get the data, clean it as much as possible, and directly insert into data warehouse. It depends on your design. So there are no right or wrong kind of a design. It depends on the use case. If you want to have raw and kind of stage-wise cleanup, you can go for data lake and data warehouse kind of a design. If you really want, okay, I want the source is there anyway. I simply want a clean data set. You can simply take it and dump it into a data warehouse. That depends on the use case. So in data engineering, basically, the ultimate job role of a data engineer is to make sure data is there in data warehouse or data lake, and you make sure these ETL jobs runs. Okay, you need to make sure they run maybe weekly, whatever it is, based on your schedule. Okay, that's the ultimate goal. And okay, so when it comes to tools and techniques, I'll just explain some tools and techniques. Mostly we use in the industry, we use Python. Oh, there's another language. It's kind of a Java-like language. There's something called Scala. Okay, it's more like Java, kind of JavaScript kind of language. So usually for big data processing, we use Scala or Python. Okay, but still we do have this Java mostly for microservices and certain other use cases we use Java. But in commonly we use Python or Scala. And anyway, okay, SQL is kind of given. So whatever you do, SQL will be there anyway. And when it comes to processing, so I'll mostly focus on kind of big data designs here rather than basic designs, the domains. So you can't actually process the data as a normal data sets. Like mostly we are familiar with files, no? Maybe Excel files, ESV. That's what we do in university. But in reality, we get variety of data, and for our case, especially for PICME, we have huge amount of data. So we actually use big data technologies to process this. I'll explain the different ways we process this, but in general, we use Spark for processing. So Apache Spark is our tool. So in any case, if you have very large data sets, you can actually use Apache Spark. And when it comes to big data technologies, if you notice, most of these icons have a you know an animal. Okay, so it's kind of a zoo here. So if you have heard, when it comes to big data, we have another process called zookeeper. So what the zookeeper does say, zookeeper makes sure the cluster and everything runs, and all these processes are in place. So that's a zookeeper. So most of these icons, they have actually an animal. And when it comes to orchestration, now we talk about the details of all these jobs. There should be a place to schedule. So it should maybe you should run every day. Okay, maybe midnight or maybe weekly, monthly. So there should be schedule. So to schedule them, we need orchestration. So there are open source kind of tools like Airflow, okay, or Airflow. Or maybe if you go for cloud native services, you have Azure Data Factory and AWS, NWA. So those are actually orchestration. So they don't do anything, any processing. What they do is they simply schedule. Okay. And anyway, you have the cloud services, you have the GCP, Azure, AWS. I'll just go through them. And then when it comes to, let me clear this out. Okay. And when it comes to databases, so all this MySQL, Postgres, okay, Oracle, and MongoDB, those are more, I would say, NoSQL, these ones. Okay, these are basically SQL, RDBMS. Okay. And the databases, okay, basic databases, what we have in common is usually we have BigQuery, okay, that is more of Google's design, and then Snowflake is there, Amazon Redshift. So those are more data warehouses. Mostly data engineering, what happens is data engineering ones usually not data engineering, so data lakes, you can actually have any design. You don't need to have a third party. Let me clear this other part. Okay. So for data lakes, so you can actually use any design, like can be S3 in Amazon, or it can be basic Google storage. So it's up to your design. But when it comes to data warehouses, because that's where the data will be fetched from these the BIO, whatever the consume. Okay, so data warehouses usually we use separate tools, but still you can actually go ahead with open source. Now at PicMe, actually we don't go ahead with we are not using any of these cloud services. We mostly go ahead with full of an open source stack. Our data lake to data warehouse to everything is actually fully open source stack. So we don't invest any of these how to say cloud services. Okay, mostly we have kind of a cloud native. So once you go ahead with Snowflake is not actually cloud bound one, but if you want to be more cloud native, so rather than going ahead with cloud services, you can go with open source. You have pros and cons both. When you go for open source service, what will happen is you have more burden to maintain, and you have both sides. Okay. And when it comes to basic data storages. We have the databases, that's what we discussed, and then data lake, that is where basically everything is dumped. And some cases, if you want to read all these things further, you might see something called in data lakes. We have an issue called sometimes data becomes data swamp. Okay, what do you mean by swamp is now you dump all the data. Now. Once you dump all the data, if you don't actually use those data in long run, some data may be there forever. You simply dump, but you don't use it, right? So then we actually call them data swamp. Okay, in data warehouses, we actually clean them and use it, right? So clean them and insert. So most of the data you have in a data warehouse are mostly small and fully curated data. So the usage will be pretty much high compared to some data sets in data lake. So data lake data might not be used. Okay. And then we have this data warehouse, basically combination of data in high level. Okay. I'm telling it in high level, data lake and a data warehouse, very high. Okay. Now the other thing is, okay, you have all the data pipelines. Okay. It's not only about okay coding an ETL job and scheduling it. As an engineer, okay, we need engineers to do this. Okay. As an engineer, you need to make sure you have high quality data. Because now for a model, so now since you guys are already familiar with machine learning, if you give garbage to a model, you get garbage out now. So basically, whatever you give to a model, fully determine the output you get. You give garbage to a model, you get garbage out. Simple as that, right? So the data matters here. Okay, the pipeline accuracy matters. So basically, we call them data quality matters. Okay, so how do we check the quality? So there are different ways we can check quality. Okay, so there are different issues in data. So there can be complete an issue. That means data might not have been written properly. Okay, sometimes that can happen. But when it comes to big data technologies, if you're dumping data, sometimes basically what happens is you are writing files in most cases. So in the middle, imagine your process terminates. It's a mirror, and some data is there, some data is not there. So there can be an incomplete issue. Half data is there, half data is not there. Okay, so we should have some rules to validate this. Okay, did I write all the data? Okay, if I did, even though we wrote all the data, there can be an issue. Some data might not be there. Some Unicode issues, maybe encoding issues. So there should be another layer. Okay, do we have actual correct data in my data lake or data warehouse? Okay, are these complete? Are the record matching? Do we have any duplicates? There can be duplicates, no? So if you don't have any mechanism to avoid duplicates, there can be duplicates. Right? There can be some extreme values. So based on your algorithmic issues, maybe there can be data issues, quality issues. Okay. So usually in ETL jobs, okay, we have data coming from source to destination, and then usually in best practice, we have another quality layer. In quality layer, what it does is it makes sure whatever the data you are dumping and whatever the data you are processing have the highest quality, because that's the data you are going to use actually for a business decision. So now everybody wants to take, okay, we want to use data. So everybody goes like, we have this machine learning, that machine learning, we use data up to this level. So now data matters. So now data quality matters. So whatever the decision you are going to take on this data, okay, should be highly accurate. Okay, we are not going to talk about any machine learning yet, simply data quality. So we need to have a separate layer to make sure, okay, data is there with a high quality. Okay, that's what you call the data quality. It can be a separate job. So you dump all the data, and after dumping everything, you run another, maybe a script. Just check all the quality. If you have any quality issues, you raise maybe an alert or anything. Okay. Cool. And in data issues, now we just started, but in by data issues, and we just check the completeness. So I'll just select a couple of things, and there can be uniqueness issues. That's what I discussed. Now, if you are writing into a file, so usually when it comes to very large data sets, most of the cases we dump them into files. So when you simply dump the data into files, there can be duplicates. Unless before you dump, you remove duplicates. So if you just take them and dump it, there may be duplicates. So there can be uniqueness issues. So when you are processing them, basically you are loading some data which are having actually duplicates. Okay, and there can be consistent issues. Now, as I said, for a data lake, you're dumping data from different sources. So imagine you have one data source, two data sources. So both data sources generate more or less same data. Okay, now imagine two data timestamps. So if both data sets doesn't have more or less same timestamp, there is a consistent issue. Now there can be a scenario, one sensor is running in one time zone, other maybe another time zone, even though they're in the same country. It shouldn't be, right? So if they are in the same country, those they should run in a same timestamp if they are in a same process. Okay, so there can't be consistent issues. So when you are going to use the data, if you have these consistent issues, again you are going to have garbage information. Okay, and then when it comes to accuracy, okay, data accuracy again matters. Now what happens is, if you don't validate data, okay, now for example, imagine you are loading say age data. There may be a scenario, okay, in EDA usually we do using remove outliers, right? So you have outliers in data, but before you dump the data into a data lake, if we can remove outliers, then actually we can save some uh, time in the EDA part. So this is not basically machine learning here. So I'm not telling about, okay, going ahead with like IQR methods, but basic cleanup. Okay, you can do a basic cleanup. So if you have, say, gender, if you have male and female, okay, given that we have only male and female, okay, we can't have anything else. No, you can have male or female, or maybe you can say unknown. That's all we can have. So other than these three, we can't have anything. So if you can clean up, okay, only male or female or unknown can be there. We can't have empties. You can clean up. Okay, we don't have any missing or inaccurate data. Okay, so and then there can be formatting issues. Now, for example, one of the most trickiest data point we have in data is the date. Okay, so date can be different formats. So you can have like month, year, okay, sorry, year, month, date. And then there are other formats like month is there, date is now in the middle, year is there. Sometimes no slashes, okay. Date, month, year is there, right? So now there are different formats. So when you format them, now sometimes, okay, Sri Lankan case, okay, you write year, month, and date. Now you have different formats, right? So in a data set, we prefer every data is actually data or timestamp is in the same format. Okay, so we can validate. Okay, are they in the same time zone? For example, when it comes to our scenarios in Pygmy, we are running Pygmy at Sri Lanka, and then we are running in Nepal. So we have two different time zones. But when you are dumping data, we should make sure, okay, Pygmy data should have Sri Lankan time zone, Nepal data should have Nepal time zone. Okay, so we need to validate. So validity should be there. So we are not going to join Nepal and Pygmy data. That doesn't work. That doesn't mean anything. So, but we need to make sure whatever data come from Nepal should have Nepal things, Pygmy should have Pygmy things. Okay, and then when it comes to this data processing, you can do actual data processing in two different ways. Okay, now data can be coming in batch choice. What we mean by batch choice is you generate data. Okay, the data can be in a database. Now, an example, think like POS system. If you go to Keys or Cargill, you have the POS system. Now they generate data. So throughout the day, they do the transactions and they generate data. Now we'll just assume that data is there in their machine. We'll just assume that. Now you have two options. You can either take the data at midnight. So once they close the shop, every single day, say 11 p.m., you fetch the data from that source once per day. okay, or maybe a couple of times per day, you take batch wise, you take whole or whatever the delta. Okay, so when you fetch them, you take actually bulk. That we call actually batch processing. What do you mean batch processing is you take data as a bulk from the source and you dump it. Okay, and the other option is okay, let me check. We can clear this. Screen parts. No. Okay, I'll leave it. Okay. Now the other option is now there can be a situation. Okay, data there's no place to store. Data comes continuously. For an example, say for system, if they can't store them in the system itself, now they simply stream data. Stream means from the source you send the data, you stream them. Now we have to take the data in real time. Okay, we call it stream processing. Okay, now you don't have the luxury to process data or basically load the data as a bulk. Now you have to take the data in real time. When you get data, you have to fetch them and store them. Okay, that we call stream processing. So those are the two main ways we can actually load data. So in ETL jobs, you can do this in a batch wise. Right, batch wise means you fetch the data as a bulk. Bulk means you can do it multiple times. That's fine, but whenever you run it, you load the data in a batch. Okay, and the other thing is you can run actually these data fetching scenarios in real time. That means you run 24/7, okay, or maybe whatever the period. During the period, you are simply listening to a stream, and whenever you get the data from a stream, you process. Okay, so those are two different ways we can actually process data. So you can have a mix of this. That is totally fine, but either you take batch wise or either you process stream. And then actually, that is not a very common technique. We have something called NRTs. Okay. Now this is stream processing. Usually it's real time. You get the data in real time, you process and dump. That is real time. But there are certain scenarios you can't actually do it in real time. I imagine you get data in real time, but maybe the payloads are quite big. And before you dump it, you need to do some processing. We'll just say. So now you need the data in real time. Okay. Now imagine you have a dashboard. They want data in real time. But you can't give them in real time because the data payload is big. And before you give to the dashboard, you need to do some processing. Right. So ideally speaking, due to processing and the size of the data, you can't do it in real time. Right. What do you mean real time is whenever you get it, that is there in the dashboard. That you can't do it in practice. Then what we do is we have something called NRT or near real time. In near real time, what happens is you have actually a small delay. Okay, you process them in real time. So from source to destination or the dashboard or whatever it is, it takes a small time. Okay, so you make sure okay within this time period data is there. So it looks like real time, but it's not real time. It's near real time. Okay, so this is not actually standard way of doing it, but in practice you have to do it. No, not everything in books is there in the production. Okay, so when it comes to batch and real time in data architectures, we have actually two different setups. We have one thing called lambda architecture. In lambda architecture, what happens is we have batch data and real time data both. Okay, so this is usually the most common technique. Okay, where there are certain jobs they actually process data in batch wise, maybe midnight, maybe evening. So you do fetch data bulk wise, process and dump. That is batch mode. At the same time, there can be real time use cases. Okay, so real time use cases you need to do real time. Now, for example, when it comes to pick me, we have this lambda architecture mostly. We have set nearly 300 pipelines. They run basically at midnight. They start at 12 a.m. Okay, and we run all these 300 pipelines. Okay, and we fetch the data which are there in our production databases. Okay, and then what happens is now we have real-time data. Now all the trip data, the driver locations, those are coming in real time. So we have to process them in real time. So at the same time, we have the real-time stream processing. So we take the data in real time and we dump them and we process them. Okay. But the other design is now you don't want, no, I don't want any batch processing. I really prefer only stream processing. So you consider all your data as real time. You're not going to do any processing in batch. Every single thing you do it at a real time. So you don't run batch jobs. So what you do is all the data you run 24/7, whatever, whenever the data is there, you process and dump it. Okay, that's what you call kappa architecture. So all the data architectures you have to either be lambda or kappa. Okay, basically in lambda, what happens is message. Okay, we will okay, where are the data lake? Okay, basically this is basically how we design the data lake. Okay, so in the data lake, so what you do is you take the data and dump. No, okay, how we dump the data? Are we going to dump the bulk wise? Okay, basically data lake will be somewhere here. It's not ideally here, but this is how we process data. How we take the data and dump it. In which manner are we going to do it 24/7? Or are we going to do it batch wise? So this is not the data. We can't actually pinpoint where the data set is. Basically, data lake is technically here. Okay, so how we dump it? Are we going to dump in real time or are we going to dump in batch wise? That's what I'm discussing here. Okay, cool. And the other thing is when it comes to data engineering, okay, one of the other key requirement is all your ETL jobs, the data, we should have high reliability. For example, when you have a data set, okay, if they are failing almost every day, what's the point of having ETL? So you go to office and you switch on. Imagine you are a manager, okay, and every morning you need to take a decision on what happened yesterday, okay. And when you go to office, you don't have data because okay, these ETL jobs did not run last night or in the morning, whatever it is. So we don't have data, right? So there's no reliability in the data pipelines. Ideally, they should run in the morning or whatever the design, and for management decision making, they should be ready. Okay, so management should be able to rely on this data. As engineers, what we should do is we should make sure our ETL pipelines, our data design is solid. Okay, that's what we call the reliability. And then there can there should be scalable. Now, when it comes to big data designs, the volume can change, the variety can change. For example, just focus on volume. Now we'll just say at pick me, I'll just take an example. These days we are doing more or less nearly 350,000 hires, 3.5 lakhs hires per day, right? Because this is a season. After out of season, it may be dropped, maybe 300, right? But now our pipeline should be able to handle all the up and down data scaling. Now, when the data is increasing, the ETL job should be able to handle the large. And when the data set is small, the ETL job should run in a small, resource because you don't want to throw up all the resources just to waste resources, right? So scaling up and down is another consideration you should do. When the data set is small, you spend only small compute resources. When the data set is big, you spend large resources. But whatever it is, whatever the data size in this case, it should handle them efficiently. Okay. And finally, okay, it can be very reliable data design. It can be fully scalable. But if you can't maintain, now there should be a set of people to maintain. You need to make sure, okay, if something goes wrong, we can be it can be rectified or adding new things. Okay, upgrading. So technically, maintaining is another key. Right? If it is very difficult to maintain, that's another issue. That means it's really difficult to add a new feature, change thing. That's kind of a disaster. Okay, in a very good data platform, if you are going to be a data engineer, we need to consider, okay, the reliability of the platform, scalability of the platform, and mainly the maintainability. Okay, and the other thing is, in data, we have something called data governance. What do you mean by data governance is, okay, now all this time what we talk about was data coming from source to destination and how we process and the tools techniques. And the other thing is now, I think last week or something, we had a news, one of the banks of Sri Lanka has a data breach. So there's a data issue, right? So data is basically now kind of gold. Okay, we have to save our data, with all these priority and the security and etc. etc. Okay, so then when it comes to data side, we have something called data governance. Okay, what do you mean by data governance is basically who can access data. Okay, who can process data. So if you are writing, who can write onto these databases? Who can read? Okay, even reading, who can read what table? Okay, even within the table, can we read all the columns? Can we restrict columns to the different users? Now, if we have an intern, should we allow intern to write data? Okay, if we have operational people, should we allow them to check personal information? Okay, what level of security we have? Who can access databases? Who can access our data lake? And who's the owner? Okay, do we have technical lead or do we have data architect? Okay, so when it comes to data governance, we need to define all these accessibility. Okay, roles, and then you have all the security, maybe user access keys, SSH keys, all these things we put in place. Okay, quality we discussed. So quality actually goes under data governance, to be honest, in data platforms. Okay, any questions up to this? I think okay, we have a chat. There will be questions. Okay, I think we'll take them at the end. Okay, so let me move on to MLOps quickly. So all these pipelines and everything, those are more into fully data engineering. So you have the data and you dump them into data lakes or data warehouse. But nowadays everything is in this machine learning. No, okay. Now you have the data in the data lake or data warehouse, and then here comes the machine learning engineers, data scientists, blah blah blah. So they design the fanciest machine learning model. But how do we actually run this? Now everyone can build machine learning models. No, now building a machine learning model is pretty much easy nowadays. Okay, even with ChatGPT or whatever it is, you have the machine learning model now. But how do we run this model? Right. So we need to put it to production. So having a Ferrari in a garage where if you can't take it out, what's the point, right? So now you have the Ferrari. We should be able to put it on a road and use it. Okay. Now we actually have a discipline called DevOps. In DevOps, what they do is whatever the source code or the design or the software developed by software engineers, they put it to production. Now, similarly, when it comes to machine learning, the models, all the artifacts developed by machine learning engineers, there's a set of people called MLOps engineers. They put them into production and maintain. Okay, so they have the ML. They should have the ML expertise. Okay, they should know what the model, some ML expertise, and they should have the ops. Okay, or system expertise like Kubernetes. Usually we run them in Kubernetes or Cloud Ops or VM2 clusters. So all these expertise they should have because otherwise they can't deploy them. Okay, and then they should have the dev expertise. Okay, coding and all. So all together we have the ML Ops team. So why we need ML Ops is technically. Now imagine you are writing a machine learning model. Okay. Now, if you are familiar with Jupyter Notebook, technically we don't use software practices. No. If you are developing a software, we use GitHub and all these software practices. But when it comes to notebooks, usually I have never seen people using software practice. You don't commit notebooks like a normal code, right? So you get a new cell and run it. So it's a fully messy code, right? So if you want to hand over the product, okay, you are done with the ML model. Our model is fully perfect, and you want to deploy it. So how do we give it to deployment? Okay, now you have a Jupyter notebook, right? So it's not production ready. So how do we hand it over? Okay, you simply send the code, maybe email. Okay, that's not a proper practice. Right now, your software artifact, the ML model, is basically you are giving as a pickle or H5, right? And if you have multiple models, how do you version it? 1, 2, 3, 4. So you have multiple models. Now, if you do it in manually, that's going to be a disaster. Handing over the model from data scientist to ML engineer to ML ops, or so just say ops, is a disaster now. Okay, so that's where the ML ops comes into picture. What they do is they take the burden from that deployment part. So they make sure all the development to deployment to finally monitoring will be done in a fully enclosed manner. Okay, so basically what happens is, now will let me start with where's the ED? Okay, so when it comes to data science, you start with ED, and I'll just skip that. That is more for data scientist. Okay, and then you do the data preparation, EDA data prep, and then you do the development. Okay, I'll explain why this is in DevOps. So in data science, what we do is we do EDA prep, model training, review. Okay, that's usually data scientist job, and then we have to deploy it. That means you put it to production. Okay, in production you have to do inference, so say prediction. But once you develop a machine learning model and once you put it to production, you can't actually forget about the model. So you have to check the quality of the model, because with time, data changes. Now, for example, if I give an small example, now if you have been in Kohuala, this Kohuala Junction, now there's a flyover. But a couple of months back, that was actually under construction. So at Pygmy, we have set of machine learning models to predict the traffic and basically the time, right? So the model we trained before opening of this flyover versus after the flyover is completely different, right? The traffic pattern is fully different, right? So data changes. Now the model we had before the flyover versus the after the flyover is basically the model we had before. It doesn't work now. It works, but whatever the prediction gives is completely wrong because data is changed, right? So we call that data drift. Now data is changed. So we need to monitor our models, whether the models are good enough now, right? Good enough for production use. Model differs, okay? And we have more new models coming in, okay? Should we improve the model? Do we have data drift? Do we have model drift, model change? All these things we have to monitor, right? So now, as a data scientist, you can do all this now, okay? And once you put the data model into say production, now there can be situation, okay, the model quality drops, right? Now imagine, okay, today you have accuracy of 90% accuracy. After 5 months, your accuracy drops around say 78. Now you are not happy with 78 because you have a threshold of 80. So your target was 80. Now the model accuracy has dropped below 80. Then what you can do is you can retrain the model because now data has changed. Okay, so you can retrain the model with new data. Now in retraining, you have to do this, right? You have to do the data prep. Sometimes you have to do this, creating a new model, and you have to retrain, maybe hyperparameter tune to everything. Okay, now this is there. Earlier, this was there in data engineers, data scientist works. Now, if you want to automate this, now every day you in every model you can't do this now. So you deploy today, and after 2 months again you are going to do the same. That is not going to be practical. So now you want to automate this. That's where the MLOps comes into picture. You can automate this. Okay, you deploy a model and you periodically check whether the model is good or bad. If the model is good enough, you use for inference. You predict. If the model is not that good, you retrain. Or maybe develop a new model or do a high parameter tuning. This should be automated. Okay, that's what we call MLOps pipelines. in MLOps pipelines, we run all these. Okay, so every period, maybe monthly, okay, maybe monthly, or maybe weekly, okay, maybe daily, okay, you check the model quality. If not, you retrain. And sometimes what will happen is, okay, you retrain the model, and the model actually after retraining, the model accuracy is even below the current model. Now you have actually a new version, but the new version is not good compared to the old version. So now you can have two options. Either go ahead with the previous version or the current version, unless you build another model, right? So now you have to have different versions. If the new version is not good, don't deploy it. Now you have to make sure this is fully automated. And if you are not familiar with hyperparameter tuning, the tweaking of all these parameters, we should know what the parameters we used. And for each parameter setting, what for the model performance. Okay. And we call them logs, matrices, right? All the matrices, accuracy to precision to everything we should have in a log. What was the precision of my previous model? What was the precision of my current model? Or model to version 1, or 2, or etc. So we should have logs for each matrices, right? So that's why we need to have monitoring. Okay. So when it comes to machine learning, it's not about just develop the model and leave it. So we need to deploy it, we need to use for inference, we need to monitor them and retrain. So this is basically an iterative cycle. Okay, so this is kind of not never ending. So all the models you need to check, and if not good, retrain or develop. Okay, so that's why we need to do the MLOps pipeline. And technically, okay, I use the same slide set even very recently in a AI workshop. In machine learning pipeline, technically speaking, only this part is machine learning. No? Only the machine learning code. Okay, data verification. It's not technically machine learning. It's more of stat. Okay, it's kind of deterministic. Okay, and deployment anyway is not machine learning. Okay, and EDA. Okay, we'll just say EDA is also machine learning. Data collection is not machine learning. Data pre-processing is not machine learning. So most of the things, I would say 70 to 80% of the portion of this machine learning pipeline is not actually machine learning. Okay, it's not non-machine learning things. So as a machine learning pipeline, we have very small machine learning code. All the others are non-machine learning code, so non-machine learning processes. Okay, that's what we have in in this. So other than this one, okay, these parts, all the others are non-machine learning. Okay, we'll just say inference. All the others are non-machine learning components. So in MLOps pipeline, we build all these non-machine learning things together to create a holistic view of end-to-end machine learning pipeline. That's the ultimate idea of MLOps pipeline. So the people who does this, basically we call them MLOps engineers. Okay. So in certain cases, we don't have separate MLOps engineers. It's basically data scientists itself. It depends on the company. So some companies we have different MLOps engineers. Some companies we have the same people will do will do the same all this stuff. Okay. And when you go for ML development, I'll just get this one. Okay. So in machine learning model, this is what I actually discussed. In a model, with time, model performance drops or model quality drops. But if we can refresh the model periodically, okay, this dotted line is dash line is basically if we didn't do anything, this is how the model quality is going to drop. Okay, but at this point, I will retrain my model. We'll just say retraining. I'm not going to go for new one. I'm retraining with the latest data. Now, one example, say ChatGPT. So ChatGPT, GPT models, they train, they'll say up to 2024 December. And after a couple of months, they may retrain again with the new data. Likewise, at this point, okay, I'm going to retraining. So I don't want my model accuracy to drop below this point. So whenever it hits the threshold, I will retrain it. So likewise, here, so you have the same pattern basically, but you don't let it drop below a certain threshold, right? So you keep on retraining the model. Yeah, I'm retraining again. Okay, so on average, the model accuracy will be kind of consistent. It starts dropping, but we don't let it drop below a certain threshold. That's why we actually need model refreshment. Okay, we need to refresh the model, maybe with new hyperparameters, maybe with new features. Now feature selection. So you have the feature selection now. Feature selection actually you can automate. Okay, there are plenty of feature selection algorithms you can automate. Okay, in the same pipeline. And hyperparameter tuning. So you can run all these random search or bit search or whatever it is in the same pipeline. So you run everything in the pipeline and let the pipeline decide the best model and simply deploy whatever the best model. Okay, that's the end-to-end pipeline. So we start with EDA. Okay, and you do the EDA part. That is more of, we'll just leave it. Okay, and then we have the data preparation. Okay, we have to pre-process data, clean the data, and then you have the develop model. So you train the model. Okay, you are training the model, and then after training the model, then you have to deploy the model. Okay, and once you deploy it, now it's in production. Okay, and then you predict the prediction part, and then you have to monitor. Okay, simply you keep an eye on the model whether the accuracy drops. Okay, maybe data drift or model drift, and if that drop, you retrain it. You again retrain the model, and you simply keep on going in the same cycle over and over again, unless you want to maybe deploy a new model or another version, etc. Okay, that's basically the whole idea of MLOps. So ideally, I have another set of slides with ML flow. That's one of the MLOps tools, but I don't think I have time to go through that. So what I will do is I'll just jump to some questions. I think that should be fine. So I couple of slides in ML flow that might take another half an hour. So rather than taking more time, what I will do is we'll just go for some questions. I'm sure you guys will have more interesting questions. So please ask questions. So my designation is a principal data scientist, but I head the data science and engineering team. So I have very good data engineering team here. One of the best teams I have. So just ask if you have any questions. So this is what we do day to day life. So we have very large data sets. So I'll try my best to answer most of the questions. Just please throw your questions. I think there's a QR code to ask questions. Is there any questions? Okay, there are a couple of questions here. I'll start from the bottom. Okay, we have a device and 10-second ECG data by real time. We have ML model to identify the abnormalities and have only save on level. What tech? Okay, so in real time processing, okay, usually in our case we use Kafka. Okay, then Kafka is the for streaming. Okay, I'll tell the processing. Streaming you can have Kafka or RabbitMQ kind of techniques. For processing, okay, you can use Apache Spark Streaming, or you have Flink. Apache Flink is there, and then we have Beam. So those are more big data processing. Okay, so even if even with a basic Python, you can do all this processing unless you have a large data set coming in or very high velocity data. Okay, so in this 10-second ECG, usually I assume that is not, you don't need it in real time prediction. So you basically have to wait for 10 seconds. If I'm not mistaken, you're asking 10-second ECG. Okay. Unless the data is coming in a single payload, you have to wait for 10-second time frame. So ideally, you can't do it in real time. That's more of near real time. So you can either use Spark streaming. I'm assuming kind of a large data set, or basically Flink. Flink is another very good. Spark streaming is more micro batch processing. So they do real time, but in micro batches, whereas Flink is fully real time. So you can either go for one of those, or you can simply go ahead with Python. So in simple Python, if the data set is having a low velocity and a small payload, you can simply go ahead with basic Python based consumer design. Mm. Yeah, I'll share the slides. I'm not sure how to share it. I'll share it with the how to say, the organizers. So just they will share it with you guys. Can you explain what is a data pipeline? Okay. So what do you mean by data pipeline is? Okay, the slide. Let me go to slide. Get a normal. Yeah. So ideally, what do you mean by data pipeline is? So you have the data. Okay. So you have seen pipes, right? Okay. In a pipe, data goes from A to B or B one way, right? So water. Okay, water goes from one side only one way. You don't have two-way water. So in a pipeline, usually data flows from one side to the other side. Okay, usually, unless you have fully messy cyclic designs. So in a data pipeline, we have different steps. You extract from the data source, basically read, okay, and then you do some transformation, maybe data cleanup or maybe data processing, some sort of data crunching, and finally you dump the data. You write them into a source. That's what you call the ETL jobs. So in data pipelines, more or less, that's what we have: reading, do something, writing back. Okay. Um, the thing I discuss which technical skills and what level of projects would expect. Okay, so that's a very good one. So basically, that's what I said. It's really difficult to get this data engineering skills in undergrads because you don't get these tools and data sets to play with. So having a basic knowledge is totally fine because you can. There are cloud services. They will give you actually free credits. Okay, so with free credits, you can spin up these Spark clusters and get quite a large data set, and you play with the data there. Okay, you can create all these Spark jobs, ETL jobs there, and if you have very basic understanding, should be fine because from undergraduate, it's really difficult to expect a very high level of data engine knowledge because by design or by your curriculum, you don't get the chance to work with these techniques. So that's kind of unfortunate. But nowadays, you have the luxury to go and play with all these tools and techniques using cloud services. That's the best you can do. So having one cloud service, so basically high level idea of I would say Spark. Okay, my preference is Spark mostly, Spark knowledge, and basic big data technology knowledge is more than enough. Based okay, auto scaling. There's open source tools for auto scale. Okay, that's actually to be honest a kind of subjective one. If you are doing more of microservice level deployments, if you have microservice level modeling, one of the best one is Kubernetes or K8s. So in K8s, you can have more scalable and fault tolerance kind of thing. If not, you can go for auto scaling clusters. Okay, so that's kind of subjective one. So that's why I gave kind of a high level answer. If you can just explain more, I can give more kind of a granular one. Um, what are the job roles? So basically, job role itself is we call the MLOps engineers. In usually some cases, they don't actually identify as MLOps engineers. So you have the data scientist or ML engineer kind of designation, but you do more or less both. You develop the model and you deploy it. Now, an example in Pygmy, we have a separate DevOps team, but we don't have a separate MLOps team. Data science team itself is basically managing the MLOps pipelines. We have the CI/CD pipelines from DevOps, but the entire ML machine learning model lifecycle is technically managed by the data science team. So our data scientists and data engineers, they are more capable, they are capable of managing this. So we don't have separate dev MLOps designation. We have data engineer and data scientist. So our data scientists and data engineers, they actually manage these ones. So there's no, in our case, we don't have separate designation as such, but there are companies, they have this designation. That's kind of a new one now. What invalid data situations have you faced in last? Okay, so again, invalid data is actually, to be honest, kind of another use case based scenario. For an example, one of our data sets are the location, GPS. Sometimes, GPS is fully messy. Some GPS locations may be on sea. At the moment, we don't operate on sea. We simply have vehicles on land. So now there is a valid area of land in Sri Lanka. So we actually validate the locations before we fetch them. So those kind of invalid data technically based on the use case. For example, if you have age, which we actually don't have in at Pygmy, if it is an age, based on Guinness records, we can't have person who's 200 years no. So that's one of an invalid data set. So you can actually curate those data, right? So likewise, the invalidation is, to be honest, kind of based on the use case. That depends on the use case, and then you have to come up with the technique to identify the use case. And how long does it take to identify? It depends. Sometimes, unless you see an anomaly in the data, sometimes you might not even actually know you have an invalid data there, right? So that might be an example. Say gender. So now in Sri Lanka we have male, female. In some countries we have large number of genders, right? So there can be a situation if you have given in your forms any gender can be typed. So some people can come up with a new gender now, right? So in the data you might have totally different gender variation, which is actually not valid. So it might take some time to get up to that. That's why I said the data quality depends on the use case. So basically, how do we process the data and what do you actually process? Okay, what are the qualifications? Okay, for interns, to be honest, okay, interns are coming to learn something. Okay, so personally, okay, I'm from Moratuwa, so we went for internships, etc. So we want to go to the industry as an intern. You want to go to the industry to learn something. So if we are expecting from an intern to an expert level, that's not fair by the intern. So from us, what we expect is technically you should be able to kind of having a critical thinking, problem solving knowledge. Otherwise, no point of having. Okay, and some basic data background. Data background means you should have some basic idea of machine learning, some big data technology. That is more than enough, and willing to learn. Okay, because at Pygmy, so it was more into Pygmy scenario. At Pygmy, as I said, we have fully open source platform. Okay, I have worked for 5 other companies. This is my sixth company. Pygmy is my sixth company. So we did not have this level of data platform in any of the other companies. I have worked for multinational companies, but none of those companies have this kind of an open source, sophisticated design. So we have nearly 300, more than 300 actually ETL jobs running every single day, and we have real time data. We actually every driver's location we fetch every 10 seconds. So we have nearly 100,000 active drivers per day. So you can calculate the number of data points we process per day. 100,000, 10 seconds throughout the day. whenever you are active. So whether you are in a trip or not, we fetch the location. So you can imagine the data load we process. So we have a complete open source kind of sophisticated data platform at PicMe. Okay, so it's very nice to work on. So but it's a bit difficult to adapt. But if once you get adapt to this kind of open source platform, cloud native services are this piece of cake, because nowadays cloud service platforms they offer more drag and drop, very no code or low code solution. Whereas when it comes to open source, it's full of kind of fully coding, and it's not that easy as compared to most of the cloud services. So if you are so if you have gone through the difficult part, that's my personal view. Okay, so working on a cloud service is just nothing. Okay, that's my thinking. What do you think? Okay, it's a very common question I get. So AI engineer. Okay, so personally, it's really difficult to replace these people, right? My personal opinion is, so people think, okay, the jobs will be lost due to AI, and so ideally what happens is, based on my experience, what I see, what I think is, the job of AI and ML engineers are basically becoming more easier now. Now, okay, I'll tell you something. So before ChatGPT comes, actually I design a model to compare duplicate images. So images, basically those are kind of bills. Okay. So those days we didn't have anything called vector databases. It was before, it was around 2018. Okay. So we had to design all these systems. We didn't have ChatGPT to ask all these. We had to go through all the documentation, everything. Okay. So the model we designed in 2018, after ChatGPT and all these emerging vector databases to everything, now that model is actually kind of a waste. Waste in the sense, we can do the same thing more easier. It's very easy to implement nowadays, right? So as a data scientist, compared to 2018, now it's very easy. Okay, so it's very easy to work with all these AI platforms. So now our jobs are more easier. Okay, so they every day now we get kind of new models, new techniques, all these things. Now there are plenty of things to learn. So I don't think jobs will be get replaced. But only thing is, if you are not going ahead with all these things, that what will happen is, then you will get replaced if you are not following the AI kind of hype, not hype, basically the knowledge. Okay, let me check whether we have anything else. Is using open source tools for better. Okay, I'll tell you why we mostly use open source. Okay, now for example, in practice, before you get into a vehicle, you might be putting pick me and Uber both. No? We will face the reality. Okay, you may be comparing. So whatever the low price you might get it, that's your money, right? So that may be a choice. Now imagine I can simply go for very sophisticated, very fancy cloud service system. Nothing comes for free in cloud services. Okay, so will you pay more money for Pick Me or Uber, whatever? Uber does the same thing, in my knowledge, based on the things I have read. If I'm not mistaken. Okay, so based on their things, mostly open source tools they are using, and plenty of things they have made open source. They are very good at tech, to be honest, leading the market, leading the tech in that side. So whereas in Sri Lanka, the market leader is technically Pygmy. Pygmy has the more market share in Sri Lanka. So how we have come to that point is, we use technology at a lower cost. Okay, so whatever we do, we try to optimize the cost. We do more efficient things with a lower cost. So open source tools, yes, to be honest, bit difficult to manage, but we make sure we manage these open source tools with a very low cost and high efficiency. Okay, so that we can actually compete with the global giants. So Uber runs in nearly 40 countries. It's a world multinational kind of a platform, whereas Pikmi runs in only two countries. So we are competing with a global giant, and we have been able to actually overcome that. So we are actually leading the market. How we use all these techniques, mostly I'm talking about the data platform. At data side, we make sure everything runs high efficient with a very low cost, so that we can be more effective and low cost when it comes to the pricing. So we have other strategies, but mostly the other thing is, one of my decision is I don't want to stick to a single cloud service. Okay, so what will happen is, if you stick to a single cloud service, what will happen is, if they double the price, you are fully stuck, right? So our data platform, how we have built this, it's kind of cloud agnostic. Now we are in GCP. If you want to go to Azure maybe next month, our design is kind of lift and shift. It will be a migration, but it's still doable. But most of the platform, if you stick with say Azure or AWS, or basically fully cloud native services, you can't do the lift and shift. So you are stuck there mostly. Whereas in our case, it's kind of lift and shift. So we can change the cloud service if we really want. So that's kind of easy to migrate. Okay, seems like the questions are done. Any more questions, guys? And if you have any questions, you can easily find me in LinkedIn. Just drop me a message in LinkedIn. I'm more than happy to help you guys. Yeah, over to you.
All right. Thank you very much, Mr. Ian, for for that insightful and extremely valuable session. I think you answered a lot of questions as well that our participants had. So thank you very much. And since all the questions are done, we'll now move on from Q&A session on to a very exciting session for all of our participants. So before we wrap things up, just a reminder on something I mentioned at the start of the session. I teased that something exciting is coming up, and that moment is now. So after an incredibly competitive and creative preliminary round of DataCrunch, it's finally time to reveal the finalists of DataCrunch 2025. The finalists are these teams on screen now are the finalists of DataCrunch 2025. A huge congratulations to all these teams who impressed us with their ideas, technical skills, and data-driven solutions. I'll go through the list of teams who will be entering the final of DataCrunch 2025. These teams are mentioned in no particular order, so they are just mentioned. All of these teams will be making it through to the final. The teams are Team Caramel Labs, Team DeepSync, Team Hack Squad, Team Hello World 2.0, Team HyperQ, Team Forte Bytes, Team The Trial Lumen, Team Rainmakers, Team Synexis, Team VFork, and Team X-Force. So once again, a massive congratulations to all of these teams for entering the finals. The teams who are going through to the finals will be contacted by the organizing committee very soon. So do stay in touch for that as well. All right, so before we wrap things up, it is time to capture this moment in time forever. So I'd kindly request everyone to turn on your cameras and update your virtual background to the one that's been shared in the chat right now. And it would be lovely to see all your smiling faces as well. So please do turn on your cameras and update your virtual background so we can take a photo. If you just check the Zoom chat, you'll find the virtual background there. We have a few shy people, I guess. Please do turn on your cameras so we can take a group photo to finish our event. All right, then looks like we do have a lot of shy people in the audience. Shall we take the photo? Yeah, Akilu, you're taking the photo, yes?
So you better take the people leave.
Yeah. All right, we see some faces.
Okay, done.
All right, all good. All right, then. Thank you very much once again, Mr. Roy Ion, for taking your time to share your knowledge and your experience with us today. I think we all got a much clearer understanding of the data engineering and MLOps side of modern AI systems. And also a big thanks to all our participants for actively listening and engaging with these sessions. There was a lot of very interesting questions, which I think broadened the knowledge of all of us. So do stay tuned for the next phase of DataCrunch, and don't forget to apply what you learned today in your future projects and solutions. And with that, we can wind up the third workshop of DataCrunch 2025. Thank you all so much for joining, and have a great night.